the background subtraction, again to extract, to estimate what is the largest object size, go to the slice mode, go through different Z slice just to get a rough estimate of how big is your object size. Click again. See, this is a 5.15 micrometer, right? This is how big is 5.5. How much is this? 9. So maybe I would go for 9. Let's go for another Z section just to get an estimate. It looks bigger.
But
so 9. 2? Sorry?
Maybe that's 2.
2?
Yeah, maybe.
What?
You cannot really see whether it's 1 or 2.
Okay. Okay, yeah, but
but
just to give you, I'm not. Don't go in the biology. Yeah, you have to just focus on the largest object size. Right? So, yes, and also I'm not a biologist, so I don't understand. Okay, so yeah, 7. Right. So I would go for 8 or something. That's like a compromise.
Could you maybe repeat again when you choose absolute and when you choose the...
Okay. Yes. Yes. So in the absolute intensity, when you are very sure about, this is, you understood that what is displaying there?
Yeah.
So that's 1, right? 1, 0, 1, 0, maybe 0. In this case, I would actually not use background subtraction but go for absolute one, because I'm very sure that the background is background and foreground is very high. You see, foreground is very high, 94. But just to guys give you, because that would be very simple to show you. Yeah. So in such cases, you have to use absolute intensity. But let's use absolute intensity and then we'll come back and use background subtraction. Yeah. I think you can appreciate that. It has very well segmented, just based on the absolute intensity. Nicely. But there are some problem with the touching. They are touching together, right? And then we want to separate them. And how do we do that? And no matter how good is your segmentation or what is your threshold, see, this is a threshold of what I was talking about. This is a threshold intensity. And so whatever is above 22 would be considered as an object. Now, how do I get rid of this touching problem? But there is an algorithm. So of course, here you have to switch on. But when you switch on, what it does is basically it runs the Watershed algorithm. Right. Now, for that also, it needs to know what is the diameter of the seed point. Meaning that for this particular region, what it does is it try to find the seed point which will be of that size. So if your object, let's say this object is 2 micrometer, then and if you select the seed points as a 2.5, then there will be only one seed point, right? But if this object size is, let's say, 10 micrometer, and then if you put 2.5, then there will be 2 seed points. You understand at this point? Because it needs to know some kind of a rough estimate. And to understand this, maybe I should also go back to this presentation to make you understand what is Watershed. So, okay. The problem here is the same one here, which I discussed in the presentation, that you have this nuclei, I have segmented based on intensity, and now they have become one object, but actually they are not like this. For example, let's focus on this guy. Okay, they're one object, but I want to separate them. How do I do that? Based on Watershed. So what Watershed does is, you have this image, so first you binarize it, right? Then you have foreground and background. Now then you create a distance transform. Now what is distance transform? It's like, it's a fake image, or I would say it's a virtual image, where every pixel contains the distance instead of intensity, right? Distance from the centroid of the binary image, right? Like you can see here that it's very close. So this is basically the inverted image, right? So if you invert this image, you can get a sense of what do I mean by distance transform, meaning that the pixels, more apart the pixels is, the larger is the distance, right? Like that. and then you have to invert them before you do watershed segmentation, meaning that all the pixels which are very near, they are brighter, right? You can see it here. And with this, you can kind of guess that, okay, there must be two objects here, because you can see there are two extremas. This high intensity blob here, high intensity blob here. So basically, you get this information from just by knowing this object, and then you basically it's two objects. That's watershed. And why the name watershed? Because as if you just consider you're pouring water from the top, right? And then you have this intensity profile like this, right? And you're pouring the water from the top, and depending on where there is a catchment, right? So the catchment would be here, like in this case. So water will not stay there, right, on the top, but it will go to the catchment. And then with this, it come to know, okay, I have to cut like that. You understood, right? So and that's why the name is watershed. So go back to Imaris, and then you have to select this enable. To just know what was my size, it was around 7 or 8, right? 8, something. I will just do it like 5 or something. Oh, that's a seed point, right? It's a seed point. So now I can see that I expected. Now earlier it was one object, and now it's giving me 2 seed points. So now it has done very well. Again, you can select the quality of your watershed, right? It's again the same as a spot object, right? So depending on what is your signal to noise ratio in your image. So normally one should go for this automatic one. I think it works well in all the time, but not always. Like you see here, there are 2 objects here, and this is missing, right? So I'm just well, it's not coming. So maybe we are not looking at it from the direction there. So it's not coming. So if it is not coming, that what you wanted and you're targeted, then you have to go back and change your size. And at some point you will get that candidate, right? So it's very back and forth. You have to go back and forth, because there is no automatic way of deciding what should be the size of the seed point, right?
And could it be that this one was not marked because we chose absolute instead of...
No, it has nothing to do with absolute.
Okay.
So 2. So when you say this background subtraction, it is basically, as I said before also, either you can switch on this background subtraction in the wizard, or you do a priori in image processing, do background subtraction, create your channel, and then apply absolute. That is possible. So it's a 2 option, right? But again, as she said, that in that case, it won't be remembered in the algorithm. So I think one should avoid that if you want to process many images similarly.
But will your choice of threshold will also influence the seed point time?
Exactly. So these 2 guys are completely different, right? As you can see from this presentation also. Oh my God. Okay. And so here, when I created this object, I could have actually gone a bit higher, so that I would have created this as a separate object, this as a separate object, and that is based on what was my threshold. That's possible.
But then you might have lost something.
That's a problem, and that's why because ideally you don't need watershed, right? If you go to the very high level of the threshold, then you end up with 1 pixel here, or just group of pixel, but that's not what you want, right? Even though they are apart. So yeah, it's a compromise between these 2 criteria, right? So, like for example here, if I go, okay, I don't need now, right? It is already segmented nicely. Well, still, there is 1. But now it will influence it will be very easy to apply watershed now. Because as I told you, watershed depends on the shape, right? more is this curvature like this, then it's obviously likelihood that it is going to cut in this way. Like that. So you have to play around it, right? So maybe I'll reduce it to 3. Let's see. Now I can see this 2 points. Yeah. 2
Then you
dots.
don't get the information about the shape and the.
Sorry?
Then if you do this, then you don't get the information about the shape and sides, the true size of the.
Of the shape? Yeah. Okay. So what we are doing now is just creating a seed point for Watershed.
Okay.
Now this spot will go off now because we have created surface now. This is just an intermediate step, right? Just to create a seed point. Because seed point, for seed point, it is also using the all the algorithm for spot detection. That's why you see only spot. But if you want to see I would go for ortho surface. Here. Can you see now? And maybe I can change some color so that you can differentiate what is surface and what is the seed point for Watershed. I hope it is some. Okay, good. Can you see now? Yeah. Maybe I can change the transparency. Oh, I have to tell you about this transparency, but I will touch that later. Now you can see that. Yeah? You can also do the same thing. Change the color for seed point here. But I don't want that now because because there are 3 information now overlaying. One is a volume, then the surface, and the seed point for Watershed. So that's why I would say just off so that I can see. Okay, now I think it's clear, right? It has segmented very nicely, but still there is some problem with this guy here. There are 2 seed points, even if it is a 1 nuclei. I don't know. Again, I'm not why, so I don't know. What do you think? Is this right or wrong? Yeah.
Can you switch off the seed point?
Yeah. So if I go back here and then switch off this. Yeah.
Looks like 1.
It looks like 1, exactly. So again, I think I have to go back and increase this a little bit. So maybe 4 because I think we have changed this absolute. So let's try if it worked. Yeah. Right. So it worked very well now. So again, it depends. Depends on the user. But you should know what are these settings are. Okay. Let's go to the next one. So now you can see that there is a cut here, and that is because of this Watershed. And now the spot object has gone. There is no more spot object. Again, you can select depending on this is a filter, right? Depending on the size of the object. So, but you can do it here also, or maybe even after the creation of your wizard is possible. But if you want to apply this hypothesis on all of your data, again, it's important to do all the filtering in the wizard, so that in the wizard this information is there and it is applicable to all the images. Okay? Instead of doing it later. Sorry. So now it has segmented very well. Now the volume and the surface are in the same color, so I would change the color. Let's say to yellow maybe. Blue, right. And now because blue is very opaque, right? So I can change the transparency so that I can see the content also and also the surface information. And maybe at this stage it might make sense to use this clipping thing and other things just to see the segmentation result. Okay. I think it's very important. So by default, this is the reflection of light. So by default, it's a diffusion. So again, don't go in the details because this is a completely physics part. But it's kind of giving you how you want to represent the colors in the 3D data. So by default it's a diffusion, meaning that the reflection of light is represented by the diffusive material, as if it's a diffusive material, right? You can go for specular one. So if you want to, so specular meaning that it goes for the high refractive index, as if the material has a very high refractive index. Then the third one is the emission, meaning that the self-emission property. So it's all change the color, the color map basically. It's all change the color map. Surfaces here. But I would always go for diffusivity. Right? Okay, that's it. And you can add to this to palette, so that next time when you come, you can. So when you say add to palette, it will be added. And then if you go to palette and then the custom, this will be selected. So when you come to next time, you don't have to remember which color I have represented, right, for that particular segmentation. So, yeah. This is a very important point here. So by default, the color type would be based on just the uniform color. For all the objects, the color would be same, right? Now I can go for the statistics code, meaning that based on some criteria, I can colorize them. Like here, by default, the area. And you can see here the color bar. So the higher is the object, the brighter is, or maybe in the jet color space, the red is the color, right?
What then you choose? This statistic coded, are there different choices?
Yes.
What to base that color code on?
Okay, just a minute. So, okay, you were here, right? And then you go to color here. So by default it's a base color, and in the base color you can select on which color you want to represent. That's fine,
but
right?
On the statistics code,
on statistics
code, ways to set the statistics.
Exactly. So the statistics code, meaning that you want to represent the color based on some statistical value of the individual object, right? And then you have to define what value or what basis. So the basis is here,
Okay.
right? So one is area or ellipticity. Ellipticity meaning that there are two types of ellipticity, right? The oblate and the prolate. Oblate meaning that if it is if the radius of equatorial radius is larger than the polar radius, and the prolate is just the reverse of that, right? So you can see maybe here these guys. So they are like a ellipsoid in a horizontal position. That's why it's red. And if you change this to prolate, and this one change, somebody else will get the red color, right?
And then can you know how many are like blue and how many are green? Or
how many are rows? No, I think it depends on no. So here there's a color map. The color map. The color map is you can select this color map. So I can go for what? So these are the lookup table, right? In lookup table, you are just interpolating the data or the statistical code. So let's say my area varies from 0 to 500, right? Now, if I select jet, what jet does is, because jet has defined color map, right? So just the individual object will take the value from the jet map.
But I mean, it's not like the sports that you can have the quantification.
You do have the quantification.
I think we will see that in statistical tab. This is just a coloring thing. It has nothing to do with the quantification. Quantification, I will discuss this now.
So you cannot know, for instance, how many have this
color.
If it's based on area, you cannot know how much are red and how much are green, but you can go in your list of statistics.
Exactly. And then you can you can sort it, right? You can sort it or you can filter it. For example, in this filter option, you can add and say based on area. And here I can do this and I can know that which one of them. See, like that. It's also possible. But I was talking about the coloring thing. This is just a visualization, right? Okay. Show color bar, that's fine. Statistical code. But of course, this is very computationally expensive. Because so be careful about this. Because when you click here, because this data was small, it didn't take time. But when you click on base 2 statistics, it might take time. Because it has to compute all the statistical value for the individual objects. So I for that. Okay, then go to this statistics, or maybe before that the filtering thing. Let's say after even creation of your surface object, you want to filter out some outliers. Like for example, I want to get rid of these guys here. So how do I do that? Not based on area, but I delete this, but based on some position. So area. So where's my position X here? I can add the position Y. Because Z I don't care, right? So for X, for Y, first select all of them. And for X, I just want those which are there. And okay, this is very important. So you can only use this bar from left click. And if you want to make a region, then you have to say right click. Okay, so important. So here I have created the region of interest which are in the centroid based on only X and Y. Because Y doesn't make sense because there is no outlier in the Y direction as such. See here. So now I can go and say duplicate selection. So when I say this, the new surface will be created, and because my volume is on, that's why it's showing me. But now you can see I have gotten rid of the outlier. Okay. Maybe I'll change some color because this projector is not good. So maybe I'll give the intense color. Green color, maybe. Green color. Right. So that's the filtering. That's done. Again, same like spot. I can select or deselect, or I can create the new surface. How do I do that? Draw, in draw. Here you can see now the options possible for. It's the same option for spot also, which previously you couldn't see because of some problem, right? But now you can see. So here you can create the different. So I have to switch on first the volume for that. I switch off this. But I think we have actually created all the surface. But I will try to delete something. For delete, you have to go to edit menu, and in the edit menu, switch on this. I will delete this. Surface one, yes. In the edit menu, I can go to the select mode. Select this guy. Let's say I delete this case. So I can say delete here. So delete it now. Don't get confused with this one. This is different because it gives you an illusion, right? That's the mouse. Very interesting is the in motion. This is very important feature. So here you can see you don't have to change all the time, but you can kind of guess what is the depth and what is your object of interest. But again, this is very computationally expensive, so it works only for the smaller data set. But for 3D, it's very, very computationally expensive. So I switch off this, and I focus on now I will create. Right? So for creation, I will go here, and all visible channels, meaning that if I want to create an object of interest based on the maximum intensity from all the channels, which does not make sense in this case because I know a priori that I want only object based on chloroplast. Right? So I would go for channel number 2, and that's here. So here I was talking about. So there are two kind of algorithm. One is the marching cube and the magic band. That's why I don't remember, because magic band is not algorithm, but it's automatic way of doing this kind of a surface creation. So we will see both of them. So what is so I specific here. I zoom in a little bit so that I can see nicely what is my region of interest. Again, I have to switch to the select mode. And this is this cursor, right, with the variable box size. And it's asking me what is the region of interest that you want to create a surface within. Right? So here, this is my region of interest. And I just have to say shift and click, left click. Got it? So this is an algorithm again, marching cube. What it does is within this confined box, it's kind of a roll over the cube, right? And first it finds the maxima meaning that where there is a maximum intensity peak, right? And create the seed point from that, and kind of a region grow the region until it reaches to the boundary. Right? This is the marching cube, right? Similarly, this one here. So I think I did a pretty well job. But let's go for this magic band. So magic band is, well, it's really good. You select this, and it does it. Wait. Yeah. So there are two algorithms basically. They are doing the same thing, but it depends on what you want. So marching cube is a faster, and the magic cube will take time, but it's very, very good. As you can see that it driven by the morphology of the object. So if I want to create nicely, I would increase this. First I would delete this. So for deleting this, I go back again, say delete this object, and now I would come back, and with the magic band I would increase this size of your object, and you might appreciate now. See, it's a very nice regularized object, driven by the morphology of the content. That's why you should.
The shape better by making it bigger?
Bigger? Yeah, of course, yes. So now because we are confined to this particular location, right? But now, again, there is a compromise, because if you make it bigger and bigger, it might touch to the boundary of the other object. So it's a compromise. It's a user choice, right? There is no threshold as such, because it is driven by the visual feedback, right? So, but let's try that. So let's say I delete this, I come back here, and I try to increase. Let's see. Say shift. Yeah. Still. So this algorithm is basically, because every algorithm, because I know why it's not changing this shape, is because every algorithm has contingency criteria, or the what you call the iterations, right? Number of iterations. So maybe this iteration is just reached to the maximum level. That's all. So it is possible, but then you have to code it right. But I think it has done a nice job here. So okay, but this is how you add the different object, delete different object. And here maybe I should tell you now, let's say if you do not, because not all the time it is possible to have a clear non-touching object based on watershed. But what if you want to cut this object, like for example in this case, maybe there are 3 candidates here, but because of our algorithm there's just one, and I want to cut them here. And that is also possible in Imaris. You just have to select this object. So this is one object, and I want to cut, for example, here. So for cutting here, maybe many of you don't know this, and I have seen that you just kind of try to zoom in and zoom out, right, until you find a nice plane for the cutting thing. But the good example here is that you just select your object of interest here and go to fit to the selection directly. So no matter where you are, it always go to this one with a zoomed in one. And once you are here, also there is an option called center to selection. So what does it do actually when you say center to selection? I think it only works for the volume actually. So what it does is actually you rotate around this object. That would be your center. Right? It will also work for the surface and also for the volume. Right? But I think this is not useful. The most important is this fit to selection. This is very important. So no matter where you are and which direction you are in, if the selection is go to fit to selection, and now you're here. Okay, so how do I cut this? Now to cut this, I have to go to the proper plane here, and because the cutting will always happen in orthogonal, like the vertical. Right? Again, I have to change to my select mode, and again the same thing, shift and click. When I say shift and click, this is the blue line. But this blue line is because I said it's orthogonal. For you it looks like a line, but when I rotate this, you can see the plane of cutting. You see. Are you happy with that? Yes. If not, say clear CC and do it again. Change your orientation, because it all depends on the orientation of your object. Sometimes it will give you some error warning, meaning that at that particular visualization, it is not possible to have a closed surface, right? So in that case, it will give you a warning. So let's try to generate such warning. Maybe let's say here. Well, it's possible to cut. Sometime you will get this message, right? Maybe this is so perfect. But always with the Dunstan data, we always get such warning. Because this is a very easy data set, right? I mean, you can see nicely. There's a clear nuclei. Okay, so how do we do that? It's here. And then I say cut surface. So when I say cut surface, this surface will be created, separated by this one. Zoom out just to see. There, right? Maybe if you have changed your mind and you want to combine them together, you select together and say unify. And now it will become one object again. Again, you can split it, right? So it's a toggle option. Yeah, that's it. Very important property, and that's what we were discussing about this masking thing, right? So let's say you have created your segmentation like this. I switch off my volume. Only I look at. I don't highlight it. Also, maybe I should tell you now, it's possible to create the subgroup, right? I think I already showed you that. This one. So when you say duplicate, it will be duplicated. Okay. For the masking, make sure that when you do masking for all the object, make sure that you have deselected everything. Because if you select this guy, and this guy, and this guy, and then you have two options. Either you can do masking for all the object, or mask for the selected object. Now what is masking basically? We'll see that when I say deselect this. Mask all. Now I have created the segmentation mask, right? This is what I was discussing about. So you can do whatever you want to do until this point. And then you can apply this masking on your original data. But now, maybe at this point, because of creating this mask, you might have changed the content of this channel too, right? But now it's also possible to add your channels. So what I would do, I would go here, edit, and I say add channels, and again add this blank cell. So I have a multiple copy of the channels. So Control D, I have twice, right? So this upper two, the second one has been changed because I have done some kind of let's say I have done some Gaussian filtering or something like that. But I still have this second one, the chloroplast, right? I can change maybe the name. Let's say takes time. And I say the chloroplast original. the mask call, I would create on the original one. Now this is how you should do it. Right. So I have created a mask and I applied on the original one. Now what does it mean? Say duplicate channel before masking, applying the mask. At this time does not make sense because it will ask, it will retain this guy here, the original one, where the intensity is everywhere, and also it will create another channel where this is applicable. So what it will do? It will do set voxel outside surface to 0, meaning that whatever this region will be 0, and inside, if you don't select anything, it will take intensity value from that channel. Are you followed?
No.
Yeah? No? No. Okay. I know that. Because it took me long to understand. Okay. But you understand what we want to do.
No, can you, from the beginning, why are we applying mask on all? So what's the purpose of this?
What's the purpose of this? Let's say, okay, maybe with this
Sorry,
I can tell you how. No, that's fine. That's really good because then we can actually go around all these options. So if I want to delete channels, right? If I don't want any channels, which I have added, then I can do this. See, say OK. So I have deleted. Now what I have left with the original one, right? The original one. Now the meaning is that for creating the chloroplast mask, right? For this channel, because I have created the mask using this chloroplast channel, second one. And maybe I had done some kind of pre-processing on, let's say, maybe I have done some smoothing. Let's say smoothing 0.6 just to give you. Okay, and after that I have created this surface on that channel just to aid the segmentation, right? Now, if I want to quantify what is there inside, I cannot use that channel because that channel is already been smoothed. Understand?
Yeah.
Yeah. I mean, I have used that procedure just to create a nice segmentation. But once I have a segmentation, I can just put that segmentation over the original one. Because quantification must always come from your raw data. So when I say mask all here, I have only two options. And if I use now the chloroplast, as I said, it would be wrong information, right? Because when I say select channel number 2, the set voxel outside would be 0 and the set inside would be the information within that channel. Understood now why we are doing this? And what do you mean by this actually? If not, please ask me if not clear.
When would you choose the duplicate?
Okay. So when I say duplicate channel before applying mask, here it makes sense to use a duplicate, meaning that if I do not do this, it will override this channel on the second channel. I will tell you while doing that, then it will make sense to do that. So when I say duplicate channel before applying, I do not duplicate. And I say OK, my channel will be overwritten with this information. Can you see that now? Understood?
Yeah.
Now I don't have any longer my original channel. But if I want original channel also and also the applied mask, then you have to say, okay, please duplicate it. I mean, retain the original one, apply mask on that, and also create a channel with a mask. So one is with mask and without mask. If you want to with mask, without mask, then check in. And let's do it for now. But now I can't do it because I think yes, Control Z, that will work. Yes, good.
Normally you duplicate that.
Yes, normally I think you must duplicate, right, all the time. So go here, apply it on channel number 1, duplicate it here. Let's see, okay. Now if you see, there must be 3. See the mask one? Let's look at them. What they look like. Switch off. So it's mask one that we have already seen. This is first one. Right? Also, sometimes it makes sense to have a binary mask, right? Maybe what if you want to just apply that a mask on some other channel just to create a region of interest instead of you going and creating region of interest. Like for example, I will tell you some scenario. For example, the image I showed you for the CPR image, that's one is a Dapi staining and then there is foci. So if I start from nuclei staining and segment nuclei, I create a mask of nuclei and then lay over that mask on foci channel. Then I don't care about what is happening in the background because that background is already been getting rid of because of the Dapi. Right?
Yeah.
So there are different scenarios where you can use such option. Okay, done.
So for this case, you will choose mask selected.
Okay. Sorry, what was that? Manage?
Like for the DAPI scenario
Yeah.
that you told us, you would use mask selected?
I would use mask selected, yes. But if you're asking about this option, what was it? The mask one, sorry. Here, the mask one. This option, now it is my choice. If I want to retain my original DAPI or I want to override. So it's a user choice. It is not affecting your quantification, not at all. It's just like, because if you do not do this, you might lose that and you have to repeat it again. You have to import the channel again. That's why. And also you can go for random color map, meaning that it will colorize randomly. Right. Okay. And also it's very important, you can apply on some other channel also. That's what I said. So in this case, this DAPI, I would create a DAPI mask and I will apply it on the other foci channel. In this case, let's apply it on channel number 1 with the duplication and see what happens. So you can see the cell wall information. So Control D, and I would select everything except this guy, and you can see the cell wall within the chloroplast. Only cell wall within chloroplast. And maybe you can then start segmenting cell wall from this point. Don't get rid of then the background information if you know apply it. Yeah? Okay. How do you quantify it? Exactly. We'll go to the statistics now. So we are in this tab now, so I think everything is finished there. Filtering, I think I have explained. How do I filter? Go to now the statistics tab, as you can see from there. So the first by default is the overall, which will give you how many spots or surfaces are there, right? Non-reaching surfaces. And you can see that it's 180 surfaces. Yeah. Then go to the detailed one where you can get. So you have two options in the detailed version. One is the specific value, right? So this is kind of giving you the way of showing the values for all the objects. So either you can say by specific value, average value, or all values. Let's see what is specific value. And for the specific, so what I want is that I want all the values of all the object evaluated based on area. So here you can see all the values of areas for all the object, and these are the IDs. Okay. So, and when you click here, it will be segmented. So click to selection. You see that? Yeah. And you can actually sort here. I think there was some question about the sorting thing. So you can sort here. And if you want to filter a particular range, then you have to go to the filter option. And you can select the range based on area. Yeah. You can also select the multiple subgroup here. And as you can see that it has selected. And you can duplicate those subpopulation by clicking here. this is a specific area, specific values. Then for the average values, it will tell you all the criterias, but the average among all. So for the volume, this value, the median, is the median of all the volumes of the object. Right? Now for the selection, this is the values only for when you select it. So for this particular object, if I'm interested in this object, it will give you the values for that particular object. Okay? You can also create the sub-object for that, the separate surface for that. I think, yeah, any question about this here? And then of course you can export it. So if you want to only export this particular value, like average values for all, you can click here. And when if you want to export all the values, like overall including all the individual values, then you say export all.
It exports in Excel?
Yeah. It's XLS actually, the newest version. Yeah, it's readable. Okay. Do we have, sorry?
I'm come back on the mask.
Yeah, exactly, yeah. Yes, now.
Can you show again how we applied the original data set on the mask that we just created?
Yeah, I'll show you again. So you come here, here, masking. So now because everything is selected, I will change my mouse pointer, deselect everything and say mask all. And I will apply it on chloroplast or which channel that you want to select or you want to quantify from. This is what you want.
Chloroplast, because we create the surface we create on the chloroplast.
Yeah.
Right?
So the surface we created on chloroplast, right? So it depends on your hypothesis.
Yeah.
Do you want to quantify the intensity or the shape information of chloroplast,
Yeah.
or you want to quantify what is the intensity within the chloroplast but from the cell wall?
Yeah. Okay.
Like that.
That I understand.
Yeah.
Whatever. One of the two.
But was that a question?
But you don't have
No,
the
that's not the
original
question.
Oh, okay.
That's all. So here now you have
one, the modified.
the modified data and the original data, but how did you manage to import the original data within
No,
the
here
mask?
he doesn't have the original.
No, there is no original.
There is no original. I have deleted that. I have deleted that. But
Yeah, but
how do you do that?
Yeah.
That's what. Okay. That was the question. Okay. So how do I basically get again the original one and lay over my mask on the
Voila.
original? Okay.
Okay.
And also,
Good.
how do you delete this channel?
Yeah, exactly. Delete and adding channel. I think that was okay. So you go to edit here and say delete channel because I don't want to overcrowd now the list. So I will delete this guys. Mask one, delete it. And now I edit and say add channels. And here I will say blunt cell. You missed it? You want
Yeah,
okay.
but I cannot write and see it.
Well, actually I'm recording, so if you have patience to maybe go through the videos then, but it doesn't matter. So if you go edit menu here and say add channel,
And then you select.
and then you select your original data.
Okay.
IMS format is fine. So plant cell, Control D, and you can see now that you have a cell wall, chloroplast, but now it is confusing, right?
Yeah,
So you can,
which one is which one? How do you
yeah, so always, so it's
click?
first in, first out. No, last in, first out strategy. So meaning that whatever you see in the last,
Okay.
in the down, that would be the recent one. Right. So first is always older, so it starts from top to bottom. But to get rid of this confusion, maybe it's better practice to click here and change the name. Right. This is very time consuming. I would say original because it has to compute all the MIP information, because he doesn't know that we are not interested in MIP, but it does it by default. So I would say it's original. I would say, okay. Similarly for the second one, right?
Yeah.
Just to,
But now when we go to statistics,
Yeah.
all the number we have are based on the original data.
no,
on which we have to.
Yeah, we have to select that. We have to select that. Wait, there are two questions here. Well, let me finish this part.
Okay.
So let's say we have created this original now. I close this. Now come back to this masking option.
Mhm.
Okay. In masking option, I can create this mask, or I can actually, I don't have to do this at all. Once I have done this original one, I can go back to your statistics, and here I select what? Variable. This variables, which value, specific value. Yeah, here. So here I can say, okay, but here there's a problem that the name wouldn't appear here. You have to remember the sequence. So now I can see the channel number. I think it's the third one, right? Because then if you have confusion, you can Control D and say this. If I want to quantify the intensity, original intensity of a cell wall, then it's a number 3. So okay, I can go here and say mean intensity of channel number 3. Yeah, here. So these are the intensity of original cell wall confined by the mask.
Okay.
So you don't have to do that, all these things. You need that when you want to, let's say, if you want to represent in the presentation that this is how the original data would look like after segmentation. In that scenario, or maybe the scenario that I explained, you first segment DAPI and lay over that DAPI channel on the foci channel, and then you run a spot detection algorithm on the masked foci channel. Yeah. So there are different ways to decide. But if you just want to quantify them, this is the way.
Yeah, but you have to select the right one. So
Yeah,
you have to select the one with the original data that you just applied on.
Exactly. I mean, one should know that.
Yeah, that's important, but it's not the same.
Yeah. But this is really, I mean, they could have just given you the option not based on the channel number, but the name instead. Okay.
Yeah, thank you.
But also be careful about what you select, the median or the minimum and the max. It's all statistics, right? And the center intensity. Yeah, that's it. And
one more question. Can you please go back again, because I'm forgetting it already, for the masking?
for the masking.
How do you do this again?
For the masking, let's say I have this mask, right?
Right.
Why it's a mask wall? Because I want to mask all the object, using all the object. Let's say I have segmented everything, but now I am only interested in some particular anatomical information. Right? Then what I would do, I would go here, select my mode, and maybe I'm interested in this guy here, this guy, and this guy. And I only want to focus only on these 3 objects. Then I can go here.
So you put the surface selection. I'm just a bit confused with the channels and stuff. So
no. The channel has nothing to do with that.
Right. Okay. So it's from the surface.
Yeah. Because see, whatever you do here is only for visualization.
Right.
It has nothing to do with the statistics. The statistics will come from the channels we already have.
Okay.
And then you go here and then you can select all the channels.
Right. And if you want to have several masks, then you kind of create several subsets, like surfaces, shadows, whatever. And then, if, for example, you want to apply several masks for the channel, how do you do that?
Several masks on one channel?
Yeah, for example, or...
Yeah, first of all, you have to create, so you can only create one channel based on one mask. You can't combine the masks.
Right.
But what you can do is, if you want to combine the information using 2 masks, you create one channel using one mask, create another channel on one mask, and then you do arithmetic operation. That's possible. And that's where I want to show you the MATLAB.
Okay.
If it's not possible.
So you can, if you create now a new mask, you can mask an already masked channel.
If you create a mask.
Like if you do mask, then can you use it on, for example, one of the channels that you created before?
See,
right?
whatever you see here, you can apply everything. It doesn't matter. Now, let's do that, what you said. Let's say it's a mask channel, we don't have it here, but let's create that and apply it on, again, the mask one. So I would, where was it? So I would say mask all. I would create on this original and then create it. So I have done a duplication. So now you can see there are this guy here, right? And now you said that you want to apply the mask on this again, right?
Yeah, if you have a different mask.
Yeah, exactly. Yes, you can do that because this is a channel, right? This is very important to understand. This is channel, so you can just see, go and just to visualize. That's why I switched on, just to visualize. It has nothing to do with that. You can see this channel. Now it's my choice. Now I can create surface on that. I can create spot on that, or I can create. I have to click there and then I say mask all, and now I select this. That's possible.
If, for example, I want to do, for different channels, two masks. So then, does it have an option? So if you kind of put into masks, which masks? Mask, basically mask number 1 or mask number 2 to choose for the channel.
For the particular channel.
Yeah. Or you have to.
No, but I understand. I think you're thinking the other way around because this option is not come with the channel, but it comes with the surface.
Okay, but
see,
yeah.
This is surface, and the mask is a property for the surface, not for the.
Yeah, exactly. But for example, I have surface 2.
Let's say, okay, you have a surface 2, for example.
Yeah.
Yes. Yeah.
And then I want to apply mask from surface 3, for example, on red channel, and mask from surface 1 to green channel.
Yes.
How do I mean?
They are independent, right?
Yeah.
Okay,
Yeah.
independently. So I go to surface 3, right?
Yeah.
And I go to, because now we haven't created.
It's surface 1.
Yeah, surface 1. Let's say surface 1 here, and then I say mask all.
Okay.
Select
selection of
the channel. I create another
Right.
one channel using this one, and then I get to that.
Okay, I see.
And then you can do arithmetic operation. Also, it's very important. Let's say if you want to, you have created 2 masks using 2 different channels, and then you want to find a region of interest which is common to these 2 channels. That's also very interesting, right? In that case, how do you do that? In that case, very important is you go to mask all, but then you don't create the channel, but you just want to create the binary mask, right? Because then you can add 2 binary masks. So it's like a logical AND operation. Are you aware of logical AND operation? Meaning that, let's say I have one image. There's a big circle which is white and everything is black. Now I have another image, but I have a smaller circle which is white and everything is black. Now when I add them together, wherever there is a pair of 1, 1, only that will be retained, and if either of them is 0, it will be 0. That's a logical AND operation. So what you end up is basically only the smaller circle, which is, I think, intersection. That's the, you understand, right? Yeah. Intersection. Okay. So if you want to have an intersection of 2 masks, then you don't have to say constant inside, but set voxel outside to 0 for sure. But for inside, I don't want the information from that channel. Okay, but I want, now in this case, it doesn't matter what channel you select here, because you don't get information, but here you say 200. Now what will happen, I can actually create this, so that it would be better understanding. Now you can see that, deselect everything, come back, select what, select this, can you see now? Everything is red now, everything is 200. Maybe the slice mode is better. So if you see, all of them are 200. You see the last channel, and everything else is 0. 0. Now you create this one using one surface, create another using another surface, and then you do logical AND operation using MATLAB.
That's MATLAB. Okay.
Yeah, and then you can create the region. Yeah.
we used the absolute intensity, but we didn't do the
Yeah, exactly. Thanks for remembering. So let's do that. So I think we have this surface 3, that's good. And we do region of interest, no, I don't want, using now the original data. I think it's the same because we haven't done any pre-processing, right? Smoothing, okay, I'm okay with that. Let's go for a background subtraction. For background subtraction, again rolling ball. So I would go here, Control D. I want to see what's the data. I think it's around 6, 8. Okay, fine. I'll put around 5 micrometers. Why is it showing? Because sometimes you might not see the surface after thresholding, so you might have to go to the settings here, even if you are within the wizard, and then you have to, ISO surface is on. I'm wondering why. You have to switch on this ISO surface. I'm wondering why it's not showing. Because the surface is not on, see? So sometimes it happens, right? Exactly. And now you have this. Again, this is the same as the threshold, right? What is the region of interest? So I would go for automatic. Maybe this is good for me. But still there is a problem here now.
So it's more
Again, I said that this data is not good to illustrate the significance of local contrast. Because data itself is very good for absolute intensity. Yeah? But this is how one should do, right? The only change is basically having this parameter. And in absolute, you don't have this parameter, right? That's it. Because this watershed is also applicable to local contrast. So you say enable here, and I think what did we use? Do you remember? Was 4 or 5?
3
It was.
at the end.
I think we changed it back to 5 now.
Yeah, I think so.
Okay, so I'll just go for 5 and then we'll come back.
So you use this option if you have maybe very thick.
Uneven, exactly. When you have uneven illumination, different intensity for different object, and even if you want them object to be treated equally, then you have to do local contrast. So let's go for this. That's it. And it might take longer because then it also has an overhead for background subtraction using roll. But I think it is better than the previous one. We can also show. And okay, so we have seen that now, how to extract all the parameters. Okay, first try to finish this. Yeah. I think I will go for the Vantage now. Yeah, let's go for that. So I have segmented everything now. Here. So either you can do it here, you can compute statistics. So up until now, it was possible in the previous version, right? That you can export the data, and then you have to use some other software like a Spotfire to visualize the data. But now they have also included the data visualization features to Imaris, and that is called as a Vantage view. So once you extract the information from your segmented object, you can visualize the data in a different dimension. So what you do is you simply click the Vantage. And you will be shown your segmented object. And by default, so this is also kind of a wizard, right? First we'll start from wizard. And by default, if it is a 3D data, it will go for X, Y, and Z, 3 dimension. So it will project your segmented object in three dimension. And because in our data set, in Surpass we have 2 segmented objects, it will project everything together. But maybe we are not interested in finding the first one, which was created using absolute, right? Only with a local contrast here. So I would only visualize this data, X and Y. So I would go here, next. So in next one, I have an option. So there are basically 4 different ways you can plot your data. So one is related to time. So if you don't have a time-lapse data, this will be deactivated. Otherwise, you can see also track and everything across time, and also the movement of the object. XYZ, either you can go for 2D information, just XYZ, or XYZ and scale. So let's go for this. So what I'm going to see here is XYZ is a position, but I think this has to be a Z area. Maybe I have to change this. Either you can do it here or just finish this, go back. Here, sorry. Maybe I will rebuild it. So source data, and I'll rebuild it and go back, go there. XYZ. So this is using color, but okay, now you can see XYZ position. So X coordinate, Y coordinate, Z coordinate, but it is also possible to change it, and I'm just wondering why it is not. So XYZ. Okay, so because I have different versions of Imaris, and they keep on changing this option. So now here you can see that when you click individually, then only it is possible to change the different criteria. So when you click on the first XYZ, nothing you can do it here, right? There is nothing. It's just XYZ, X, Y, and Z with respect to XYZ. But if you want to add some other parameter, let's say scale, but now it is adding this area, I don't know why. But you can change that also. So you can change user sphericity. Right? So now what you see here is that you have a position in X, position in Y, and this is the area, and the scale is based on sphericity, meaning that the size of the object is based on the sphericity. The best one is actually gallery. So gallery, you can see your object, and you can sort by not position but by volume, let's say, so that you can see the largest volume there. Okay. Now I also have the option here. You can also scale that based on, let's say, sphericity. Now you can see. Also the good part is that it will kind of give you, this is why it is called as a Vantage, because you can see and visualize all this segmented object. And let's say if you are interested in one particular object, then you will change your mode to select this guy, it's yellow, and go back to your surpass view, and that will be highlighted. This is very interesting, very important. Right? I mean, it was possible here also, because then you can sort it, but now it's more systematic. Right? So go to Vantage view. And sort by volume. You can also scatter plot. So in scatter, okay, that was actually scatter that I was looking for. So here you can change and play around the different options. So X, Y, Z. Now I can change to position Z. So now everything is an X, Y, Z, and now I want to colorize them based on the volume or intensity, mean intensity of force. This is how you should test now. Though you have original data, which is channel number 1, channel number 4, right? No, what was that? No, channel number 3 now. Oh no, I had to count 1, 2, 3.
It's a bit confused.
3. Oh, third one.
But at least I know it's possible, and if I need more help,
Yeah.
to you.
Oh, but there is a numbering goes from top to bottom.
Don't exactly.
It's difficult to take all the information, so
But I think
when you
that's-
don't have a specific problem, but at least we know it's possible.
Yeah, but I think what I would do, once I finish my segmentation thing, I would delete the channels which is not interested or interesting for quantification.
Yeah.
So what I would do, I would just go here, I had to go to the surface view, and in edit, I would say delete channel, and I would just delete this guy, this, maybe this, and just one. Yeah, I mean, I understand. I think that's a limitation. I mean, for them, it's just a one-line code to change instead of ranking a number, just go by the name, right? But then still we will have confusion because we have many different names. So now we have done this.
And the duplication.
Yeah, exactly. And now you are left with only one channel right now. Go to scatter, and if you go here, then only channel number 1. Okay, what is this channel number 2 is there? Okay, so 1 and 2. Right. Again, you have to go back, see what is your interest. No, it is not possible. You have to be in surface view and go for Control D. So that's the second one. Vantage. Go for the second channel. So I will go for the mean intensity of channel number 2. Mean intensity of channel. So this is what essentially. So yeah, the chloroplast. I mean the intensity of cell wall confined by the chloroplast. This is what it means. And then you can visualize in different way, right? We have seen that. Position, and you can have a number of columns and rows depending on what visualization you have.
You can also sort by intensity.
Yeah, exactly. Yes, so sort by intensity here. Channel number 2. Okay, you have to. Channel number 2. Right, there's a mean intensity of channel number 2. Yes.
Yeah.
So you can see that. So it depends on what you want to visualize, right? And then you change it to this thing. You can zoom in also. If you think that this is completely rubbish, then just select this guy. And also you can see what's the value, which you already have in the statistics toolbox. Right? Yeah, so you can see this is a column, a row basically for this. And you can go back to surface view. And here you might be interesting to see fit to selection, and now you can directly go there. And you can switch off there and see what's the volume to investigate what's happening for that particular thing. That's it. And you can take a snapshot of, I think, Vantage. Oh, yeah, it's also possible with Vantage. Yeah, Vantage 1. But it makes sense to go for the surface view. So you can take a snapshot. So for snapshot, you can change this thing. But there is also option to say, because there is a lot of background, right? So if you click this, this will be there. The good practice is that actually say fit. That's really nice. So when you say fit, everything will be fitted and this will be your image.
However, the scale bar isn't still there because no one
Scale bar, it's not there. I think it is there. It's just that it's very small, that's why.
But you can move it.
I think, yeah, of course you can move it. I showed you, right? And you can, oh, sorry. Yeah, I like that. You can go it anywhere. Yeah. Good. And then you can change your image size. So you can select the resolution like DPI. This is very important for publication. If you want to publish, then they have a very specification for DPI dots per inch. Then a snapshot size from a window size, meaning that whatever is showing there, I just want that. If you do not want that, and if you go for 100% snapshot, this will be deselected, but the size of the image would be huge. Meaning that the size of the image would be the same as the size of the volume in XY plane. So do not use this 100% snapshot. Doesn't make sense. because you can see the width and the height, 6,000, it's too big. So do not use this, but use this thing. So now it's become 649. So you can put it in a presentation. You can save it to the file, or also you can copy to the clipboard, right? So if you're simultaneously, if your PowerPoint presentation is on, you can say do snapshot, and now it is already saved in your memory. So you just have to go to PowerPoint and say Control P, paste, because it's already copied to the clipboard. Otherwise, it will be saved with this name in your, here. You have to select your path. Okay. What else? Animation. I don't know if we have time for the animation. I mean, I don't have any problem. You just have to see if you have time. Otherwise, we can cover it in the next if you want. Or
maybe in the next, because I don't think I can English it anymore.
Exactly. I think it's too much. I understand.
Yeah, I cannot. I start to lose a lot of information now.
Then we have to go for this Imaris cell, Imaris tracking. We have to cover that in the next also.
Yeah.
There are a lot of things.
For tracking the nice.
But actually we are good. Actually we have covered a lot, at least the basics. And then we have to cover the co-localization also. But that will be next, or maybe next to next. It's too many things to. Yeah, but animation will take time, so maybe I think we'll do next time.
Thanks a lot.
Yeah,
I think it was useful.
Yeah, very nice.
Okay.
Very nice.
For the one that used already and the one that don't use.
Okay.
Because
I also
get a lot of
forgot
things.
for the Fiji thing. I haven't, but maybe the next time again. How to, what you said basically now, that in your algorithm, right? So your question was that is it possible to remember what you do before the wizard, right?
Yeah.
Because when you create a wizard, the creation wizard,
Yeah.
and then that algorithm is only thing is remembered for this one is that whatever you do in the wizard. So you don't remember what you do at your previously and later.
Yeah.
But that is possible using MATLAB script that we have written.
Okay.
That we can create all the settings, and then you have to just call a function from here and say run this function. It will run all the pre-processing steps, and then it's possible. So you don't have to do it manually.
Yeah.
Of course, you have to be consistent for all the data set.
Yeah.
If you keep on changing the background subtraction, then okay, it's possible.
Yeah.
But that's possible.
Good.
We'll cover that next. Okay, thank you guys.
Okay, thanks a lot.
Yeah.
It's not fun.